Let f be the continuous function defined on the closed interval whose graph consisting of 3 line segments and a semicircle is given. G is the function g of x equals the integral from 1 to x of f of t dt. And they want us to find g of 2 and g of negative 2. So g of 2 is the integral from 1 to 2 of f of t dt. And remember, that means area under the curve from 1 to 2. So from 1 until 2, we have this negative area under the curve. It's a triangle. I see that the base of that triangle is 1, but what's that negative height? So I see for this line segment, you go over 2, down 1. So for this piece, I go over 1, down 1/2. So that means this height is negative 1/2. So g of 2 equals area of a triangle 1/2 times base times height, which is negative 1/4. So now we're going to do the same thing, but we want g of negative 2, which is the integral from 1 to negative 2 of f of t dt. But remember, when evaluating definite integrals, your lower limit needs to be less than your upper limit. So this becomes negative integral from negative 2 to 1 of f of t dt. So from negative 2 until 1, and here's negative 2 until negative 1, gives me this triangle with a base of 1 and a height of 3. And then from negative 1 to 1, it is a negative semicircle. So g of negative 2 is 1/2 times base times height, and then it's going to be subtracting 1/2 pi times your radius squared. So this becomes g of negative 2 is 3 minus pi over 2. So we can evaluate definite integrals with geometric area.